Hello class, I made several videos available for chapter 3 and the problems. I'm really assigning some problems from the middle to the end of the chapter, but I want to show you something. There's this page, Math is Fun, that I like. It's very simple to understand the concepts. It gives you, there is the visual, which sometimes it's easier to remember, and explains in details. And usually at the end of the page, it gives you problems that you can try on your own. So why don't we go ahead and try some? One thing that I'm going to be using here, Excel, that I put in here for you, is that for probabilities, the best way to do is always to have um, the total number of outcomes. That's the one that I get first, and then the total number of ways it can happen. That's why you're going to get your fraction. So let's just go ahead and try. So this is going to make more sense. Let's try question one. Oh, here it is. So a die is thrown once right here. What is the probability that the score is a factor of 6? Okay, so first of all, we know that a die has 6 sides. You can get anything from 1 to 6, right? And also factors of 6, that means numbers we can divide. So it's gonna be, we can divide 6 by 1, and then 6 and 2, 6 and 3, 6 and 4, no, 6 and 5, no, 6 and 6. Okay, so we have 4. So number of ways it can happen, 4. So my answer should be 4, 6. And if we look in here, we don't have it. So if we divide both by 2, so we're going to get a 2 third right here. Three number of ways it can happen and total number of outcomes. So factors of 6 are 1, 2, 3, and 6. So four ways it can happen. Total number of outcomes 6. So the probability is 4, 6 divided, so it's 2/3. Perfect. Let's try another one. It says the diagram is showing the spinner made out of a piece of card. It has a toothpick through its center. And the 5 triangles, here's what matter. The 5 triangles are numbered from 1 to 5. So we know number of outcomes 5. We know the bottom is going to be 5, so it couldn't possibly be this one. The spinner is spun until it lands on one of the 5 edges. What is the probability that the number it lands on is odd? So how many odd numbers we have? One, two, we have 3 odd numbers. So my answer would be 3/5. So they do have an option right here, and we are correct. Number of ways it can happen. So there are 3 odd numbers, 5 total comes. Probability is 3/5. Okay, next. Each letter of the word Mississippi are written on separate pieces of paper and then folded, put in a hat, mix. One piece of paper is chosen without looking. Where's the probability it is a letter I? Well, Mississippi has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so total of number of outcomes is 11. From here, I would think already this is the answer, but let's keep going. How many letters I? 1, 2, 3, 4. There you go. 4 letters, so 411. Why did I think? Because the other numbers would have to be, if they have divided this, it wouldn't be integers. So for letter I's, 11 total for 11. Okay, next. Okay, so a card is chosen at random from a deck of 52 playing cards. Here we go. We have our total. There are 4 queens and 4 kings. What is the probability the card chosen is a queen or a king? So we have 8, so we have to include all of them. Say 52. So right here, obviously, they reduce the fraction. So let's go ahead and divide it 8 by 4, that's 2, and 52 by 4, that's 13, correct? 52 by 4, 13. Okay, so over here 13, so my fraction is 213, which there is a choice right here. So there are four queens, four kings, so 8 ways it can happen, 52 outcomes. So they did 852 divided in by 4, and then they got 213. Next. I know I'm going quite fast here, but I'm just showing you um, that it sounds very complicated, and they throw a lot of wording, and a lot of times you don't need all that wording. You just really need to see what put it on a paper what could possibly happen. Okay, so now a fair coin is tossed 3 times. What is the probability of obtaining one head and two tails? A fair coin is one that is not loaded, so there is an equal chance of it landing heads up or tails up. Okay. So 3 times. Okay, so let's go ahead and put the combinations. We can have a head, 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 correct? Oops. We can come up with a head, head, and a tail. We can come up with a head, tail, and a head. And then head, tail, tail, correct? Yeah, okay. Then now let's do tail. Let's start with tail, head, head. We can do a tail, head, tail, correct? We can also have a tail, tail, head, and we can also have a tail, tail, and tail, right? I think I got them all. One, two, three, 3 times. Okay, so that's one, two, three, four. So that's 8 outcomes. Okay, so I'm asking for one head and two tails. So let's go ahead and eliminate the ones we don't need. So one head, two tails. So that one head, two tails. Oh, there you go. And then head, tail. Okay, here you go. So we have head, tail, tail, head, tail, tail, head, tail, tail. That's 3 outcomes. So my answer should be right here. 3/8. There you go. Had. Okay, exactly. So there are three number outcomes, 8. Perfect. Okay, next. A committee of 3 chosen from 5 counselors. Adams, Burke, Cobb, Dewey, and Evans. Oh, A, B, C, D, and E. What is the probability Burke is on the committee? Well, first of all, we got to put all the combinations. Let's put all the possible combinations A can go with for 3 out of the 5. So A, B, and C. We have A, B, and D. We have A, B, and E. But we also have A, C, and E. Then we have A, D, and E. That's done. Okay, let's go for B. B, C, and D. We can do B, C, and E. B, C, and E. Okay. And B, D, and E. Correct? Okay, and the last one is going to be C, D, and E. And that's all because we already have ABC, we already have CBD. Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Make sure I have everybody. Adamsburg, A, B, D, A, B, E, A, C. Oh, what is this? AC, I'm missing one, right? A, D, E. Oh, hold on a second. We can also do A, um, C, D. We don't have that, do we? We have C, E. Okay, A, D, E, A, C, D. Okay. And, I think I got everybody covered. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 ways it can happen. Where's the probability? Burke is on the committee. So there is 1, 2, 3, and 4, 5, 6. Okay, we have 6, correct? So if we look here, we don't have, we got to divide then. So divided by 2 is going to be 3/5. Okay, they're possible. Yep, exactly. So I guess the most important thing is to make sure that you have all the combinations. When you make sure you have all the combinations, then you can come up with the number of ways to happen in the total outcomes. Special dice image is made in the shape of an octahedron, I think. The die has 8 equals face marked with the numbers 1 through 8. If the die is thrown once, where's the probability that the face that lands uppermost has a prime number? Well, prime numbers, so the numbers divided only by themselves. So 2, 3, 5, let me think. 1, 2, 3, 5, 7, 8, 8. We can divide. 6, we can divide. 4, we can divide. Well, okay. So that's 4. 4 eighths divided by 2 here, I guess. Then it's going to be 1/2. Perfect. Okay. Next one. Oh, how many more? There are 10, I think. A thumbtack can land either point down, point up. Drew dropped the thumb back 100 times and found that he landed point up 38 times. Drew concluded that the probability that the thumbtack lands point up is about, well, he landed point up 38. So we're gonna do 38 divided by 100. That's about, if you round up, that's about a 40%. There you go. Perfect. That's right. Okay, next one. There are 10, take this. There are 10 counters in a bag. The contents of the bag are shaken before Maxine randomly choose one counter from the bag. What's the probability that she does not pick a red counter? Well, there are 3 red. That means there are 7 remaining. So 7. So 7, 10. That's right. Okay. Question number 10 is going to be the last one. Okay, a special die is made in the shape of a icosahedron, and its faces are numbers 1 through 20. When the die is thrown, there is an equal chance of any face landing uppermost. If the die is thrown once, where's the probability that the face that lands uppermost has a number that is a factor of 20? Eesh. Okay. So factor 20. So 1, 2, 4, 5, 6, 8, 9, 10, 20. 1, 2, 3, 4, 5, 6. So I would say 6. Divided those 3/10. 1, 2, 4, 5, 10, 20, 6, 20. Perfect. And that's all for this video. I'm gonna go ahead and go over problems 60, 62, 64. I'm gonna actually go over all 60 through 65, but I just want to give you an idea that if you do write it down, the problems in Visualize, it makes so much easier.